All right, welcome to our second numerical on auto circle. Of course, the question on the board says an engine of 250mm bore and 375mm stroke works on auto circle. The clearance volume is nothing but 0.00263 meter cube. The initial pressure and temperature are 1 bar and 50 degrees Celsius. If the maximum pressure is limited to 25 bar, we are asked to find the following. First, we are asked to find the air standard efficiency of the circle, and secondly, we are asked to find the mean effective pressure of the circle. So let's go on and solve this question. So I'm going to be saying solution first. Now, in order to solve this question, first I will be sketching the PV diagram of an auto circle. So I will be doing that first before we solve the question. Our P, which is pressure in bars, and our volume in meter cube. Of course, our processes, So, of course, this is process 1, process 2, 3, and 4. Do not forget to represent, to show that process 1 to 2 and 3 to 4 is adiabatic. Now, what do we do next? Of course, we can trace this down. This is nothing but what? V2, which is equals to V3. This is V1, is equals to V4. Of course, you can trace these two. This is P1. This is P. This is P1. This is P4. This is P2. This is P3. So this is what we have. So we are asked to find the air standard efficiency of the circle and also the mean effective pressure of the circle. Now, the first thing we are going to be doing is, you know, that in order to find the air standard efficiency of the circle, we are going to be needing the compression ratio. And from the data we have here, we're given the bore of an engine, which is what? 350mm bore. So our D, you can say data is given. Our D, which is diameter, is equals to what? Is equal to 250mm. 250mm converted to meter is nothing but what? 0.25. We have 0.250 meter. Next, we have a stroke of 375mm. That is the length of stroke. So our length of stroke is equal to what? 375mm. 375mm, which is equal to 0.375 meter. Next, what do we have? We have a clearance volume of 0.0. So we have our V subscript C, which is clearance volume, is nothing but 0.00263 meter cube. So this is our clearance volume. Next, of course, you can see here that we have an initial pressure and temperature, which are of 1 bar and 50 degrees Celsius. So P1, which is our initial pressure, is equals to 1 bar, and our T1, which is our initial temperature, is equal to 50 degrees Celsius plus 273 in order to convert to Kelvin. Now, if we add 50 plus 273, what are we going to get? We are going to get what? We are going to get 323. It's going to be 323. So we have 323 Kelvin. We have, okay, our parameters are complete. Now let's go over to solve this question. Now, the first thing we are going to be doing is that we are going to be looking for our swept volume. I will know that swept volume is equal to what? Pi by 4 d square L, where d is nothing but what? Our diameter of our cylinder bore, and L is nothing but the length of stroke. So we can substitute our values here and find our swept volume. Our swept volume, V subscript S, will be equal to what? Pi by 4 multiplied by d square. Our d square is nothing but 0.250. So we have 0.250 all square multiplied by our length, which is 0.375. So we have 0.375. So this is what we have. So what will be our swept volume? It will be nothing but 0.0184 meter cube. So we have 0.0184 meter cube. So press your calculator and just do this little arithmetic here. You get the swept volume. So next, we are going to be looking for our compression ratio. And our compression ratio is equals to what? Swept volume plus what? Clearance volume all over what? All divided by our clearance volume. That is our compression ratio. So from this formula here, we can find our compression ratio. So let's substitute our values and do that immediately. So we have our swept volume to be equal to 0.0184. This will be plus our clearance volume, which is equal to 0.00263. We have 0.00263 all over what? Our clearance volume, which is 0.00263. So if you sum this and do the division, you are going to realize that our compression ratio is nothing but what? 8. So compression ratio is equals to 8. Now, from what we have here, we can find our first question, which is what? The air standard efficiency of the circle. So number one, we are looking for what? The air standard efficiency. So efficiency of Otto, which is equals to 1 minus 1 all over what? All over compression ratio into gamma to the power of gamma minus 1. Now we have the value of gamma. Of course, we can find our efficiency. So this will be equal to what? It will be equal to 1 minus 1 all over what? All over 8 to the power of what? 1 point. We're not given gamma, but we know gamma to be what? To be what? 1.4 as a constant value. So we have 1.4 minus 1. This is what we have. Of course, 1.4 minus 1 is nothing but 0.4. So we have 1 minus 1 all over 8 to the power of 0.4. Now, if you punch this in your calculator, you will have nothing but what? Let's do that and get the answer. We are going to be, our efficiency now will be equal to what? If you press that in your calculator, our efficiency will be nothing but equal to 0.565. So we have 0.565. Of course, we are not leaving it like this. We are going to be multiplying it by 100. So the efficiency of the Otto circle will be equal to, 56.5%. So this is the air standard efficiency of the Otto circle. Now, what are we asked to find next? We are asked to find the mean effective pressure. Now, of course, we know the formula for our mean effective pressure. We have to find the mean effective pressure, which is equal to what? It is equal to P1 compression ratio into compression ratio power of gamma minus 1 close bracket into what? Alpha minus 1 close bracket. all over what? Alpha minus 1, all over gamma, all over alpha minus 1. Then we have all over, this is supposed to be gamma, don't make that mistake, this is supposed to be gamma minus 1 into what? Compression ratio minus 1. So this is what we have. Okay, this is what we have as our formula. Now if you look at this formula, of course we have the value of P1, we have the value of compression ratio, we have the value of gamma. What we don't have is our alpha. We don't have the value of alpha. And how do we calculate the value of alpha? Now from our diagram here, from process 1 to 2, we can deduce that P1 V1 gamma is equals to what? P2 V2 gamma. Of course, from this relation, we can make P2 the subject of this relation. If we make P2 the subject of this relation, we are going to be dividing both sides by V2 gamma, V2 gamma. So if we do this, you realize that P2 will be equal to P1 into what? V1 all over what? V2 all to the power of gamma. I hope you get this step. Now next, we have the value of P1, which is 1 bar. We have the value of V1 all over V2, which is our compression ratio, which is what? 6.25. And we have the value of gamma, which is 1.4. So we can substitute and solve immediately. So we have P2 to be equals to P1, which is 1, multiplied by what? Multiplied by 6.25, which is our compression ratio, all to the power of 1.4. Now punch this in your calculator. You realize that P2 will be nothing but 18.38 bar. So P2 will be 18.38 bar. So this is what we have as our value for P2. This is what we have. So next, from here, we are going to be, don't forget, our aim is to get the value for alpha. And of course, alpha is used to denote the pressure ratio, which is nothing but P3 all over P2. And from this question here, we were given P3. Were we given P3? We were not given P3. Question which I cleaned earlier, we were given the value of P3, which is the maximum pressure, to be nothing but 25 bar. So of course we have our value for P2, and P3 was given to be 25 bar. So from there we can calculate the value of alpha, which is of course the pressure ratio, because we know that P3 all over what? All over P2 is equals to what? Alpha. So we know the value of P2, which is what? Which is 18.38 bar. So we can substitute by saying 25 all over 18.38 is equals to what? Alpha. Now 25 all over what? 13.38 will give us what? It will be nothing but our of course, like I said, our alpha will be equal to what? 1.36. So from what we have here, we can substitute directly into this formula and we will get our value for mean effective pressure. So let's do that. So mean effective pressure will be equal to what? It will be equal to P1. Our P1 is 1 multiplied by compression ratio, which is 6.25, all into the bracket of what? Of compression ratio, which is 6.25, into the power of gamma minus 1, which is 1.4 minus 1 minus 1, close bracket, into what? Into the bracket of what? Of alpha, which is 1.36 minus 1, close the bracket, all over what? All over gamma minus 1, which is 1.4 minus 1, into the bracket of what? Compression ratio, which is 6.25 minus 1. So this is what we are having. So all we need to do is to simplify this. Of course, you solve what is inside the bracket, and then you multiply the two, then you multiply with everything here. You do your division, you are going to get your value for mean effective pressure. If you do that correctly, your value for mean effective pressure will be nothing but what? 1.334 bar. So our mean effective pressure will be equal to 1.334 bar. 1.334 bar. So this is our value for our mean effective pressure. That's and this is our value for what? For our efficiency. So we have successfully calculated the air standard efficiency of this Otto cycle and the mean effective pressure. I hope this video was helpful. If you have any question, of course, you can leave it in the comment section and it will be attended to. Kindly like, subscribe to our channel and share this video in order for us to, of course, improve and for the video to meet a lot of people who are, of course, in need of it. So thank you for watching and stay tuned for more numericals on Otto cycle. Thank you.